We're so bad.
Alright, so this is the 6-period video we'll be doing every third one, starting with number 1. Obviously the other ones are posted in the same place this one's posted, in the Google Drive with all those resources. Number 1, graph and label each complex number on the complex graph provided. So that's even got them labeled here, real and imaginary. So we'll go back 5 and down 8. So there's point A. 6, negative 9. So right 6, down 9. Negative 7, 6 is point C. Over 3, up 5, or point 5 for point D. And the others are even easier. 9I would be up there, that's E. F is 8 on the positive, or on the positive real axis, I guess I should say. Negative 3I would be down 3. And negative 2 would be left 2. And then right points E, F, G, and H in polar form or trig form. So point E is 9I, that's right there. So its R is, so trig form is R cis theta, so we need an R and a theta. R is how far is it from the origin? Well, it's 9 from the origin, and its angle is pi over 2. F is 8 away from the origin, and its angle is 0. G is 3 away from the origin, and its angle is 3 pi over 2. And H is 2 away from the origin, its angle is pi. R is always going to be positive when we write R cis theta, and the angle will control whether it's negative or not. Number 4, which of the following is equivalent to, that's pretty easy, we could have answered that probably early this semester as soon as we learned what cosine of pi over 6 is. Root 3 over 2. Sine of pi over 6 is a half. Distribute the 2, and root 3 plus I. That's about as easy as it gets. Number 7, go the other way. So now we have this is kind of the same thing. It's in cis or trig format, and we want to change it into A plus BI format. So 2/5 cosine 7 pi over 4 plus I sine 7 pi over 4. This is the step that some of you are starting to omit because you're just thinking in your head, what's the cosine of 7 pi over 4? That'd be root 2 over 2. And the sine of 7 pi over 4 is negative root 2 over 2. And then distribute the 2/5. Whoops, wait a minute. The 2's will cancel. So root 2 over 5 minus root 2 over 5I. From trig to standard form. Number 10. Fairly straightforward, but we haven't done one of these in a while. Write the value of 2 cis this angle times 2 cis that angle. So what do we do with the 2 and the 7? Just multiply them, so 14. And what do I do with the angles? Add the angles, so multiply the numbers up front, add the angles. Let's see, that would be 10/12 and 5/12 is negative 15/12. But that reduces to, if I divide by 3, Negative 5 pi over 4. And why is that not quite the right answer? Standard form. Ugh, it's annoying. Gotta keep going back and forth here. Negative 5 pi over 4, some of you probably would just say, alright, I know where that is. Let's just roll with that. Others would think, I don't want to mess with a negative angle, so I'm going to add 2 pi. I'm going to add 8 pi over 4. That would land me at 3 pi over 4. Right, that's the same place. So if you're comfortable with negative angles, feel free to use them. If you don't like going backwards or you're afraid you're going to land in the wrong spot, then add 2 pi to get a better angle. I keep meaning to skip this step, but oh well. Let's see. Cosine 3 pi over 4 is negative root 2 over 2. Sine of 3 pi over 4 is positive root 2 over 2. Distribute the 7. Negative 7 root 2 plus 7 root 2 I. So that was the trick where you multiply the numbers, add the angles, and then convert. 13. One of these days we're going to hit one that we can leave in trig form, but for now, standard form. So got to do the work on the problem, but then change it to standard form. Okay, 8 times 9 divided by 18 times 2. Okay, so that's not bad. 2. And then the top angles I'll add, and I'll subtract the bottoms. Let's see here. I'm going to go ahead and make everybody a 6. So 10 pi over 6 plus 11 pi over 6 minus, because we're in the bottom now, minus 3 pi over 6 minus pi over 3 would be 2 pi over 6. So the two top angles are positive, the two bottom angles are negative. I'm double checking to make sure I did all my common denominators right. 5/3, 11/6, pi over 2, pi over 3. Okay, so 21 minus 5 is 16 pi over 6, also known as 8 pi over 3. Bigger than 2 pi, maybe you know right where it is. Maybe you want to subtract 2 pi to get a better angle to deal with. So 2 cis. Let's see, if I subtract 6/3, that lands me at 2/3. I'm going to skip a step. Finally remember to do it. 2 pi over 3. Cosine would be negative a half. Sine would be root 3 over 2. So negative 1 plus root 3 I. I feel like I'm just cruising through these. I hope you can cruise through them as well. Number 16. Please let me leave one in trig form. No, but not bad. Which of the following complex numbers? So just convert, and what would you end up with? 10 plus 10i, that would be 10 right and 10 up. Officially, I guess I'm supposed to do a squared plus b squared equals c squared, but if you recognize that it's one of those special right triangles, then you can jump right to 10 square root of 2. Then do that, and that narrows it all the way down. But the angle, you can do inverse tangent of y over x, but hopefully you can look at that and be like, oh, that's right in the middle of the first quadrant, so that's pi over 4. So 10 root 2 cis pi over 4. Number 19. Write your answers in reduced trig form. Okay, finally we get one that we like. So I don't have to change it back to a plus b. I can leave it in r cis theta. There are, I think, 2 on the test that you do have to pay attention to that. Most of them are multiple choice, and like all the answer choices are one form or the other, so you wouldn't mess that up. But there are 2 free response where you will have to be careful and make sure you read, what form we want. I think I bolded it or italicized it. I did something to try to call your attention to it because I didn't want you to lose points just because you left it in the wrong form. Okay, 5th roots. So something to the 5th equals negative 16 plus 16 root 3 I. Okay, so I'd like to raise both sides to the 1/5, but I can't do that yet. That would be a mess right here. Let's get this into r cis theta format. So back 16, up 16 root 3. I can get the theta about right away. Theta is 2 pi over 3. I guess that's out of order, but that's the one I recognize first. And then a squared plus b squared equals c squared. Somebody want to make a better offer than me having to do that?
32.
Where's 32 come from?
I worked it out. That's 2x.
Okay. Yeah, it's a squared root of 3, and since this is a 30, 60, 90, the hypotenuse is 2a, so 32. On the test, there aren't any numbers that big, so if you did do a squared plus b squared equals c squared for all of them, you'd be fine. You're not going to be having to square 16 and 16 root 3 and try to add those together and then recognize that that's 32 squared. So 32 cis 2 pi over 3. Okay. So that was step 1. Make it a trig number. Now I can do the trick where I raise both sides to the 1/5. Take the 5th root of both sides. 32 to the 1/5 is 2. And then multiply the angle and the power. So that'd be 2 pi over 15. And that's my first answer. I know I'm supposed to have 5 answers. So I need to add 2 pi over 5 a bunch of times, which would be the same thing as 6 pi over 15. So 2 cis 8 pi over 15. 2 cis 14 pi over 15. 2 cis 20 over 15, but 20 over 15 would reduce to 4/3. And then lastly, back to the 20. 20 plus 6 is 26 pi over 15. And I get to leave those in trig form, so we're done. You might remember that occasionally I'll go over on purpose. Like if I add one more, that would make me at 32 pi over 15, which is 2/15 past 2 pi. So that would make me, that would match up with my first answer, and I'd feel good about all those answers.
How did you find theta in like your first or second step?
Oh, like way back here? So I did it very unofficially. I saw that this was a steep angle in the second quadrant, so I went with 2 pi over 3. The more official way to go would be to say tangent of theta is opposite over adjacent, which would reduce to negative square root of 3. And then I know tangent is square root of 3 at one of the over 3's. Let's see, it's negative in the second quadrant and the fourth quadrant. But my picture is clearly in the second quadrant, so it's got to be 2 pi over 3. So if you can get it by inspection, that's fine. If you want to slow down and show a little more work to make sure that that's right, that's probably a better way to go.
do you add 2 pi over 5?
Okay, I know that my 5 answers are equally spaced around the circle, and all the way around the circle is 2 pi, and I want to equally space 5 answers, so the angle between each answer needs to be 2 pi over 5.
So however many roots there are, I put that on the bottom over 2 pi.
Correct. It's always 2 pi over number of roots. And that's the step that goes between each set of angles. And that's how you find each set. You keep adding that 2 pi over whatever until you get all the angles you need. Or until you go past 2 pi. Either one. Oh, I see why they told me to leave this in trig form, because I wouldn't be able to do it in standard form anyway. Which is maybe a bit of a hint kind of built in. If we ask you for standard form and you end up with something like this, then you did something wrong, because you can't get standard form with 2 pi over 15. All right, 22. Another one with trig form. Good deal. X to the 4th, so 4 solutions. So x to the 4th equals negative 256i. But I don't want to 4th root that yet. I need to put it into trig form so that I can do the angle trick thing. So negative 256i would be down there. 256 cis 3 pi over 2. Again, you got to convert it to trig to do the math, and then sometimes we have to convert it back. Other times, like this one, we're okay. So 256 to the 1/4. Let's see. 4 to the 4th. 4 to the 1st is 4. Yeah, so the 4th root of 256 is 4. And then 3 pi over 2 times a 4th would be 3 pi over 8. And then I need to add, Ty, what do I need to add to each term? Or 2 pi over 4. Which would reduce to pi over 2. Although, given what I'm looking at here, 3 over 8, maybe it'd be better to write it as 4 pi over 8. Like, all those are the same. So I'm just getting a common denominator ahead of time here. So 3 plus 4 is 7. 7 plus 4 is 11. And 11 plus 4 is 15. That's 4 answers, so I should be good. If I do go one more, 15 eighths plus 4 eighths is 19 eighths, which is 3 past 2 pi, so that matches with, that's coterminal with my first answer. So again, I like to go one past just to kind of confirm that I did that right. Timing-wise on this test, I think you'll be fine. It took me 21 minutes, but I wrote the test, so that's not really a fair comparison. Miss Murray said it took her 25 minutes, and that was with her like showing steps, so that when we grade, it's best if we have a nice key that's already spelled out everything and point values and all that. And that still took her 25 minutes, so multiply by 2, you'll have enough time. I think you'll be okay on time. Reminder, the only thing that's due, the only 2 things that's due is worksheet 3 and 4. Because 2 I already have, and 1's too long ago, and 5 is optional.